Hi, welcome back. I have a concept that I want to show you, and that is uh, drawing with drawing with data, drawing with data lines. Actually, it's here. Let's fix this. Animating, animating with data lines. Okay, so all of these data lines are going to be numerical. So we're not talking about string data here, talking about numbers. So, like I said, it's all numerical data. And so I'm going to start putting those lines in. Data. Alright, so our first line are these coordinates here. And what that represents is two pixel positions. And I have three or four more of these lines to add. So I'm just going to do that now. So this is 96. Alright, so we have these sets of points, so every set is a pixel, and each data line is a pair of pixels. So each set of numbers is one pixel, and every data line, so each data line would be one set of pixels, meaning 2 pixels. So I have a few more to do here. And I came up with this idea by just, watching what other programmers are doing. And I sort of get my own ideas. I don't do exactly what they're doing, but they just get me started, and then I end up with some rendition. So I just want to make sure these are right by looking at my list. There's not too many of them, so you don't have to worry about that. And so there's one more set, I believe, or actually that might be it. 1, 2. I did this a while back, and it's hard to remember exactly how I did this. I think I need one more line here, but I have to make sure that it's in the right order. Now, well, one thing that I've learned about writing after writing all these computer programs, is that you develop a pretty good memory, especially when this computer doesn't offer scrolling, which is, they could have at least included that, but they didn't. So keeping up with your line numbers and everything you start to memorize blocks of data, where they are in the program, because you can't, you can list it, but you can't scroll. And but anyways, so these are all the data lines, and what this is going to do is number 2 up here, it's going to put a pixel, pretend that's a pixel, and then it's going to put another pixel down here, and the next set is going to be like between 1 and 2 o'clock, and then you're going to have another one at 3 and 9 o'clock. They're going to have one like around 5 o'clock and 11 o'clock. It's sort of like a clock, but not exactly. But so that's the best I can explain this right now. So we're done there, okay? I'm done here. And why isn't my keyboard working? Alright, I guess it is working. Let's see. So on line 7, we're gonna put I need to make a program. So we're gonna put program. I'm a little bit tired right now. It's kind of had a long day. And alright, so I'm going to put for D, which is data, I guess, equals 1 to 8. It shouldn't be 8, it should be 1, 2, 3, 1 to 5. So we have 5 data lines here. And then we're going to put for, how did this go? For D equals 1 to 5, and then I think for R for read equals 1 to 2. No, I didn't write this down. I had this program all fine and everything, but I didn't save it. So I'm having difficulty remembering how I did this. Let's see if this is right. Read X, read Y. So the first time it cycles through, it's going to ignore these data lines. When it gets down to here, D is going to equal 1. Then R is going to equal 1. And we're going to read X and Y. So we're going to get 1 pixel plot out of that. So what we need to do is put next R, and that's going to give us 2 pixel plots. So it's going to read these 2 plots, which are the 12 and 6 o'clock. 12 and 6 o'clock pixels are, okay, that's where they're located with some space in between. And it'll do that, and then it's gonna I'm gonna go to the next D, and then it's gonna do the same thing for data line 2, 3, 4, and 5. Once it has that information, it's gonna stop, and we're gonna put animation, because I told you this is an animation program, list. Now when I type list, if I press enter, once I press enter, hold down the shift key and press at, and it'll stop the listing. It'll pause the listing. So that's what I did right now. If you guys don't know that, They included that feature at least. So I can reminisce here, and it's animating with data lines, okay? I just wanted to run that by you again. So shift and at, which is this, will stop the listing, and then you press any key to continue scrolling down. So that's a trick that I learned, and it's in the book, but there's a lot of things in there that people might not have looked at. So, but anyways, so now we're going to get to our animation part, and we're going to preset. I hope I'm doing this right, and I have a feeling that I'm not, and I'm not. Yeah, this isn't right. I'm going to list this again, because once we read X and Y, we need to do something with X and Y. So before we do next D, we are going to animate list animation 14. It's going to get X and Y, and then it's going to run down through here and do preset. We're going to preset. Oh, and we have to put in one more thing here, because to enhance the graphics a little bit and make it easier to see, we're going to put if R equals 1, then preset X, Y, and the leading edge will be blue. Else preset. Oh geez, let's see here. X, Y, yeah, this is right. Else preset, we're gonna put X, Y, but our back edge here is gonna be red. So what this is gonna do is it's gonna set a pixel at 12 o'clock is a blue pixel, and set a second pixel at 6 o'clock is a red pixel, and the blue pixel is going to travel in a clockwise direction until it reaches 12 o'clock, and then it'll repeat. But we're not there yet. So we have one pixel set here. Now we need a timer for t equals 1, 2. We're just going to make it a short timer, 50. Next t. You have to include something or it'll just go too fast and the eye won't catch it. And after that, we're going to CLS the screen. But I want to CLS the screen not green. We're going to CLS the screen yellow. So it's going to be a yellow background, and we're going to list again, and I'm going to use the Shift at key. And so I need to use my 0 as a CLS 5, not 5, 2. Green is a 1, 2 is yellow, 3 is blue, 4 is red. So let's see what we have so far. Nothing, because I don't know where my mind is right now, but this should be, I don't have a graphics screen set up, guys, so I have to do that. So scrap the CLS here. We need a P mode 1, we need a screen 1, 0, and we need a PCLS 2. And we're going to list 0. We'll have to list it again. Now that's there. Here, CLS this, list it so you can see it. We have our screen set up. And so 16 is going to be PCLS 2, and 100 will go to 100. Now, when you're analyzing programs, you put stops in like this so you can see what you're doing here. Apparently whatever I did isn't working right because I'm just getting a blinking dot here, and print R. Now, how could R ever equal 3 is beyond me, because R only equals 1 to 2. Print R. How in the world can R possibly equal 3, guys? I don't know. You can see it right here for R equals 1 to 2. Read X, read at Y, next R. Read X, read Y. There's no way R should be equaling 3, guys. I don't know what's going on here. Print R. Clear. Print R. Run. Print R. It's... How in the heck... Did I double dip somewhere? I don't think I did. Now, how is that possible? I have absolutely no idea. This line 12 shouldn't be there. That's in the wrong place. So let's just scrap, delete 15 to 16. Renumber. Let's make some sense here. Renumber. List. So I have a positive list here, and it doesn't start with 0, and there's no skipping of any lines. So it's going to read X and Y. Then it's going to P set X and Y. If R equals 1, then it will make it blue. If R equals 2, it will make it red. And then 15, we're going to call a next R. Let's run that and see what happens. Now I have my blue pixel and my red pixel, and the blue is at 12 o'clock and the red is at 6 o'clock, and that's correct. So 16 is going to be our timer for t equals 1, 2. You know, the first time I wrote this, I didn't have any of these problems. I blew right through it. It's probably like 30 lines long, and I don't have the vision right now that I had before. This was several days ago, and I tossed it aside and I started working on other things because I thought it was stupid. But it really isn't. It's animating with data lines could be important. So I'm revisiting it now and I'm sharing it with you guys, but I don't have a program on hand. So it's hard to remember what I did 5 days ago, you know what I mean? So I still have the list, but I still have the coordinates, but that's all I have. I don't have a program. So after the timer, we're going to PCLS it yellow again. Let's list this. And 18, we're going to call our next. What are we going to call here? Our next D. Let's see what that does. See how that turns like that? It's like a turning of a screw, or the rotation of a clock hand or something. And let me show that to you again. 19 is going to restore our data lines, and 20 is going to go to, we're going to get rid of 100 because we don't need that there anymore. That was just like a placeholder to analyze the program. So after we restore, we want to go back, and we don't want to go to 1. We want to go to our program 1. So we're going to go to 20s, go to 8. You don't want to go all the way back to the beginning of the program. We want the program to cycle over, but it's not reading these data lines until it's asked to, and then it goes out and searches for data lines. They could be anywhere in the program. And as far as the screen setup, it's already been done. So we want to be as efficient as we can. So we want to go back to program 1. And I can see it now here. This is the whole program. So it's gonna be a loop now, what's called a loop. And you can see it turning. Okay. And that's why I did one in red and one in blue. So you can see the leading edge is blue and the back of the clock hand is red. Now if I did this the same color, it wouldn't be as obvious. But you can see that spinning in a clockwise direction. But it only goes halfway. And to remedy that, we have no other choice but to write another program and call it program 2. And I'm just simply going to copy this data, okay, for d equals 1, 2, but there's a change here because it's already at 6 o'clock, okay, so it has less steps than program 1. It only has 3 steps, if I'm doing this right. So we're going to, for d equals 1 to 3, for r, which stands for read, equals 1 to 2, and you can make these statements with any variable letter you want, but you want to make sense. You want to abbreviate so that you know as a programmer where you are in your program and what's what. So now comes our read lines, read X, read Y, that doesn't change. 25 will be animation. We're almost done here. It's like a 30-line program, maybe a little more. But what I have to do here is I'm going to say if r equals 2. Last time I put if r equals 1. But we want to reverse it because, actually, you know, alright, we're going to start there. And it's going to, can I use these lines or? Yeah, I can, but I have to check something off here. It just gets confusing. So I can use these sets. I can use the 7 o'clock set, then the 9 o'clock, and lastly the 11 o'clock. And the other ones I don't have to use. From the first data there. So actually, I don't know if I can use the data lines that are already there. I might have to put in some new data lines because I don't think I can use, here, let's just scrap this list. I don't think I can use this data because some of it is not needed. I only need these 3 lines here. So instead of restoring it, let's get rid of that restore statement. If I can find it. Alright, so that's line 19. Just get rid of that. Renumber. Right, so problem here is I need some new data lines. So it won't read the ones that were already read. It'll look for new data. And we're going to put those in, like I said, anywhere. But I want consistency. So we're going to renumber this. And I need 4 extra lines here. So we're going to renumber 24, make line 19 24. That'll give me 19, 20, 21, 22, 23. Renumber is 23, line 19. And then I'm going to stick in line 19 data. Then we'll have 20, 21, and 22 data lines. So they'll be as follows: 104, 106, wait a minute, 104, 102, 96, 110, 104, 102, 96, 110, data 106, 106, and 94, 106, and finally data 104, 110, and 96, 102. So that's it. I just couldn't use those data lines because they didn't match. Alright, so I just needed the inside 3 lines. The first one had 5. This is only 1 to 3, and it's so enough of that. Now for the animation, I forgot how I did that, and I can't see it. So I need to break it right here so I can see this information. So it's 13 through 18 that I need. So list, let me do this one more time. 13, list 13 through 18, list 13. Alright, you know what? Clear the screen, list 13 to 18. And I keep forgetting what that bottom line is. 28. List 13 to 18. List 28. This is what I mean about memory. You really got to have a good memory to be able to do this, because it's almost impossible without being able to scroll, and it's just really tough. But anyways, we want to copy this. If R equals, now the leading edge is going to be opposite. So we're going to have to say if R equals 2, then P set X, Y as a blue pixel, else if it equals 1, P set it X, Y as a red pixel. So it's the same thing, but the R value is going to be is different. Then 30, is next are 31 is our timer for t equals 1 to 50. It should be 50, not 500. Next, t, I gotta fix that. 32, PCLS2 clears the screen. 33, next, D. Let's list this, see how it's looking. D equals 1 to 3, R equals 1 to 2. List again. And it just stops at next D is where it stops, so we're good. But we need to fix that timer, that's way too long. 16, edit 16, delete one of these zeros. No, the program's almost done. 34 is going to be our restore statement so that I can make the program a loop going to 8. Listing 8 is program 1. Look at that. It's spinning around. Isn't that cool? It's spinning around like that. And that's all it took. So this is how you animate with data lines, guys. It's a smooth, turning. Alright? But I'm never satisfied. So I'm going to change this up just a slight bit. If you want to stop it here, you can. Otherwise, I'm going to list this program and I'm going to change lines 14 and line 29. So we're going to list 14, we're going to list 29. These are our graphic statements. I don't want just pixels, okay? We're going to say circle. We're going to get rid of this piece set. But a circle has a center, so it'll work just fine. But I need to insert a bracket there or a parenthesis. Color always comes second. I want a radius of 4. And it's going to be our blue circle. And we're going to have to do the same thing to our here. And we're going to get rid of piece set. And we're going to insert a radius of 4 and a color of 4. And that's it. Now edit line 29. And we're going to insert a circle statement. Get rid of piece set. Insert a radius of 4. Make sure you get rid of the old parenthesis. And I'm almost done. And get rid of the piece set statement. Insert radius of 4, not 5, 4. Color of 4, and I'm done. Now, when I run this, I'm going to have 2 circles going around each other where those pixels were. So let's run that and take a look at it. Is it okay? So that's pretty good. They're really small circles there, but they're going around each other. And that's really it right there. Now I've tried, I could make them bigger, but I would have to, and this is why I scrapped the program, because I was trying to make the circles bigger and make them farther from each other, but that doesn't work too well, and I'm going to show you why. We're going to edit 14, and we're going to increase the diameter to 10, and the same with this one. just change the 4 to a 1 and insert a 0. And I think it was 28. Well, edit, was it 29? Oh, for crying out loud. Where's that other? It's 29. And, or I could insert a 1, 0, delete the 4, go space it to the end there, and insert a 10. Shift up takes you out of insert mode. And now run it. And now we have two bigger circles, but they're kind of linked together. They're not really going around each other. And this is where I stopped, because it would require a restructuring of the program, which I didn't have time for. But maybe I'll save this program and I'll work on it a little more. And circular patterns are the hardest patterns, and trajectory patterns. I know nothing of trajectory and very little of circular patterns. So I just don't have the know-how. So I would have to do a lot of this stuff without cutting any corners, and I don't know. I know there's a way to do it. I just don't have the time right now, and I'm not sure what the circle functions look like. Maybe you guys know. You would have to have an equation, and you'd have to graph the equation and figure out how a circle function works, which I don't have time for right now. So I'll just leave you with this right now, and you guys can play with it. That's it. Like I said, what I want to do is to be able to make the circles pretty much any size or a little bigger and separate them. So they're going around like this, not linked together like that, like the small circles we're doing. But I thought it would be as simple as adding numbers to the animation sequence, but that doesn't work. What happens is they move together to another location on the screen. So I would have to study this, and by looking at this, what I have, I just don't know. I'm not that savvy in mathematics, so I'm just going to end the video right here. Hopefully you learned a little something. And I guess I'm going to end it here. I've been working on Tales of Suburbia, and I'm getting close to finishing that game. And so that's what I've been spending most of my time doing. And so that's all I have for you, and take care, and I'll see you later.